Hey folks, I apologize for the state of my voice for this video and the next one, but I'm going to push forward through this and we'll finish up the gravitation videos. This next video is a bit of a singular video on inertial versus gravitational mass. It's a strange little idea that pops up usually as one question on every AP exam. The basic idea behind this is that there are two ways to figure out the mass of an object, one using its inertial properties and one using its gravitational properties. The overriding idea is here: the mass of an object cannot change unless matter is added to or removed from the object. So this idea tells us that basically no matter how we determine the mass of an object, it will get us the same number. And if you continue learning about physics, you will eventually learn more than me, and you'll learn about how this is an idea that starts out Einstein's theory of general relativity. Anyway, let's get started. Inertial mass is based on an object's resistance to a change in velocity. So I guess one of the easiest ways to differentiate between inertial and gravitational mass is that inertial mass is based on movement and how an object moves. Galileo and then Galileo and then Newton use this idea of inertia. Inertia is proportional to mass, and the more inertia something has, the better it is at resisting acceleration. So you can determine inertial mass by applying forces to an object and observing its acceleration. So maybe you read that sentence and you see where this is going. Inertial mass is when you use net force equals mass times acceleration, and you move an object some way and find its mass that way. All right, gravitational mass is the other half here. This is based on an object's ability to attract other matter. So we've just learned about Newton's universal law of gravitation, and that basically tells us that every object creates its own gravity and attracts every other object in the universe. And so the better something can do that, the more mass it must have. What this is saying is that the force of gravity that the object both creates and the force of gravity on that object is proportional to mass. So this is not surprisingly all about gravity. So you can determine gravitational mass by measuring the gravitational force on an object. In other words, you are going to use one of the two gravity equations that we have learned, either the one that we learned that's based on little g, that is for the surface of a planet, or the one we recently learned that is based on big G, that is based on the mutual attraction between two masses that are some distance apart. You can use a balance. That's really easy. Just put it on a balance and record the mass it tells you, and that's a measurement of gravitational mass. The balance uses the force of gravity and uses 9.8 newtons per kilogram to calculate the mass of the object based on the the properties inside the balance that are changing. There's another very simple object that you probably used in like middle school called a spring scale, and you hang things from it, and you can use that force in the spring to relate to gravity. And honestly, that's it. The most that you ever do with this in AP Physics 1 is you determine whether our particular experiment is based around inertial mass or gravitational mass. And that's really it. And that's it.